In another universe, we are looking at the wrong planet. In another universe, the telescopes point to Venus, and the scientists see oceans, continents, a blue atmosphere lit by a yellow sun. In another universe, Venus is the living world, and Earth is the cautionary tale, a barren rock orbiting just slightly too far from its star. Cold, empty, a place that almost worked. The difference between those two universes is razor thin. Venus is nearly identical to Earth in size, nearly identical in mass, nearly identical in composition. It formed from the same cloud of gas and rock at the same moment in the same solar system. For the first billion years of its existence, Venus may have had liquid water on its surface, oceans, maybe weather. Maybe the slow stirring of chemistry that, on Earth, eventually became something that could look back at the stars. And then something went wrong. Something went so catastrophically, so irreversibly wrong, that Venus is now the closest thing to hell that exists in our solar system, a place where the air is acid, where the ground is hot enough to melt lead, where the pressure would crush you like a tin can before the temperature could even finish the job. A place that started as our twin and ended as our nightmare. The question is, what happened? And the answer should frighten every person alive on Earth today. Stand on the surface of Venus for 1 second, just one. The temperature is 465 degrees Celsius. Every day, every night. Venus rotates so slowly that a single Venusian day is longer than its year. But it does not matter. There is no cool side. There is no shadow that offers relief. The thick atmosphere traps heat so efficiently that the temperature barely varies between the day side and the night side, between the poles and the equator. The entire planet is the same temperature, a global oven, locked to a single setting, and the setting is on. The pressure at the surface is 92 times greater than Earth's atmospheric pressure at sea level. That is equivalent to being 900 meters underwater. Your lungs would not expand. Your blood vessels would rupture. Your suit, regardless of what it was made of, would begin to fail almost immediately. And the air itself. The air is carbon dioxide, dense, hot, crushing carbon dioxide, laced with clouds of sulfuric acid that hang in the atmosphere between 45 and 70 kilometers above the surface. Those clouds reflect sunlight beautifully. They are why Venus shines so brightly in our night sky. They are why ancient civilizations called it the morning star, a beauty that is made entirely of acid, glowing in our sky every evening as a reminder of what hides behind a pretty face. The rain that falls from those clouds never reaches the ground. It evaporates in the lower atmosphere, where the heat is too intense even for sulfuric acid to survive as a liquid. Venus has acid rain that vaporizes before it lands, a planet that poisons itself and can't even finish the job. We have landed on Venus several times. The Soviet Venera program sent a series of probes to the Venusian surface, Each one was built like a submarine, thick steel shells, reinforced against pressure, designed with the full knowledge that the environment they were descending into was actively trying to destroy them. Venera 7 was the first spacecraft to successfully transmit data from the surface of another planet. It lasted 23 minutes. 23 minutes before the heat and pressure overwhelmed it and the signal died. Later probes lasted longer. Venera 13 survived for 127 minutes, long enough to take photographs, analyze the soil, and transmit color images of the surface back to Earth. Those images are some of the most haunting ever taken. Flat, broken slabs of rock stretching out to the horizon under an orange-yellow sky. No movement, no wind visible to the camera. Just an alien landscape sitting under a crushing, acidic, superheated sky. 127 minutes. That is the longest anything built by human hands has ever survived on Venus. Then silence. Here is what keeps planetary scientists awake at night. Venus did not have to be this way. The leading theory is that early Venus was temperate, possibly habitable. It orbited at a distance from the Sun that should have allowed liquid water to exist on its surface, at least for a time. Models suggest that in its early history, Venus may have had shallow oceans for up to 2 billion years. 2 billion years. That is longer than it took for complex life to begin on Earth. And then, the oceans evaporated. As the young sun slowly brightened over billions of years, Venus began to warm. The water started to evaporate. Water vapor is a greenhouse gas. As more water entered the atmosphere, the planet warmed faster, evaporating more water, which warmed it faster still. A feedback loop with no exit. A trap that, once triggered, could not be escaped. The oceans boiled away entirely. The water molecules were broken apart by solar radiation in the upper atmosphere. The hydrogen lost to space, the oxygen absorbed by rocks. And without water to cycle through the crust, the volcanoes had no check on their emissions. Carbon dioxide poured into the atmosphere unchallenged. The greenhouse effect compounded. The temperature climbed and climbed and climbed until Venus became what it is today. Scientists call it a runaway greenhouse effect, a name that makes it sound mechanical, distant, a problem for other planets. And yet Venus is not entirely dead. In 2020, a team of scientists announced something strange. Spectroscopic analysis of Venus's atmosphere had detected phosphine, a molecule that, on Earth, is produced almost exclusively by biological processes or industrial chemistry. There is no known abiotic process that produces it in meaningful quantities. The finding was disputed, challenged, partially walked back. The data was re-examined, reprocessed, and the phosphine signal was reduced but not eliminated. The debate is not settled. If there is phosphine in the atmosphere of Venus, something is producing it. And if something is producing it, in the cloud layer between 48 and 60 kilometers altitude, where temperatures and pressures are actually Earth-like, where liquid water droplets may exist inside the sulfuric acid clouds, where the chemistry is strange and the environment is hostile but not entirely impossible, Something may be alive in the clouds of Venus. Not on the surface, not in the acid rain, not in the oven below the clouds, but in that narrow band of almost tolerable sky. Something may have survived, adapted, found a way to persist in the last habitable zone of a world that lost everything else. Microbial life, possibly, drifting in the atmosphere of a dead planet. The last survivors of a biosphere that once may have covered the surface. We do not know. We have not been able to confirm it, but we have not been able to rule it out. Venus has been there the entire time, shining in our sky every evening, bright and steady, the third brightest object visible from Earth. We named it after the goddess of beauty. We watched it rise before dawn for 10,000 years and told stories about it and wrote poems about it and navigated by it. We had no idea what it was hiding. Our twin, our mirror, our warning, burning silently in the dark.